Yeah, am I audible?
Yes, sir.
Okay, fine. So we can start now. I'm sharing my screen. Okay. Is my screen visible?
Yes, sir.
Okay, fine. Okay, so we'll start now. So this is our first question from the GATE Physics paper 2020. This is a numerical answer type question having 2 marks from electromagnetic theory. So let me read the question first. A plane electromagnetic wave of wavelength lambda is incident on a circular loop of conducting wire. The loop radius is small a, where the radius of the loop is very less than the incident wavelength lambda. The angle in degrees made by the Poynting vector with the normal to the plane of the loop to generate a maximum induced electrical signal is, so you have to find the angle for which the induced EMF will be maximum in this case. So is the question is clear to everyone? Any doubt about the question?
सर क्वेश्चन समझ में नहीं आया.
क्वेश्चन समझ में नहीं आया? कौन है ये?
हरीश.
हरीश. सो ये क्वेश्चन सो यू कैन सो क्या प्रॉब्लम हो रहा है क्वेश्चन में, वो पहले बताओ. कौन सा टर्म क्या प्रॉब्लम हो रहा है?
सर ये सर्कुलर लूप कंडक्टिंग वायर है, ठीक है.
हाँ हाँ.
और सर इसमें पॉइंटिंग वेक्टर मतलब कैसे, मतलब कुछ समझ में
Pointing
नहीं आया
vector,
इसका.
pointing vector, you know, right? That is, if
आई
you,
नो पॉइंटिंग वेक्टर. व्हाट इज
huh,
द पॉइंटिंग वेक्टर? आई नो.
huh. So what's the problem? So that doesn't depend on the loop. That is a only circular loop is given to you. So you have to find the induced EMF. Okay. So that is maximum. You don't have to worry about the structure of the loop. It doesn't really matter. The magnitude of the only the area, you know, right? I mean, the induced EMF is minus del phi del t, right, from the Lenz law. Sorry, Faraday's law. Only thing that you have to consider, you have to find a condition for which the induced EMF will be maximum. That's the thing. So if you can specify your doubt, then I can clarify that. So
सर गो फॉरवर्ड.
okay. Uh, okay, please try to solve this problem and let me know the answer. If you have any doubt during the solution, you can ask me. So, can anyone tell what to do here? I'm not getting any response from anyone. People are trying, right? Saloni Sharma, you are joining for the first time.
Yes, sir.
Can you introduce yourself, please? Yeah, can you hear me? Am I audible? Yeah.
Myself, Saloni Sharma from Bilaspur.
From Haribo?
Sir, Bilaspur HP.
Oh, okay. Okay, fine. And you are doing your masters?
Yes, sir.
So you are doing or you have passed already?
Sir, first Sam.
First sem. Okay, fine. Okay, okay. Okay, take your time and let me know the answer for this problem. So, Amit, you were trying, right?
Yes, sir.
So, any difficulty?
Sir,
Yeah, who's this?
Sir Seju.
Yeah, Sajal, please tell me.
Sir, intuitively, I'm just
Huh.
telling that
Huh.
can the answer be 90 degrees here?
I need an explanation. Otherwise, I will not
So
confirm.
90
Yeah.
in a sense, normal to the plane of the loop because that is how the flux through the loop would be maximum and that will induce the maximum current in the loop.
So you are saying pointing vector will make an angle 90 degree with the normal to the plane.
No, 0 degrees with the normal. 0 degrees with the
Pointing
normal.
vector will be along the normal to the plane, you are saying.
Yes, sir.
So your answer is 0, you are saying.
Yes, sir.
Okay. Just think about it. Just make the diagram. Okay. That will, I mean, you don't have to solve any problem also. Solve the this question also. Just make the diagram and see for which actually you need to first you have to know what should be the direction of magnetic field, right? That will give the maximum flux or minimum flux, right? And from that you can find the pointing vector, right?
So 90 degrees.
Okay, so 0 degree or 90 degree?
90. I was not considering the magnetic field, I was considering the direction of the EM wave.
Okay, okay, okay. So anyone else? Okay, just Sajil, just hold for a minute. Let me see what people are getting whether people are getting 90 degree or 0 degree or something else. Okay, then I will go to the solution. This is a very easy question. If you just if you can make the diagram for this question, the direction of the magnetic field, pointing vector, then you can easily find the angle. Nothing else. Some questions having 2 marks will be very easy. You don't have to even solve this problem. If you know the only conceptually, you can just tell the answer. Anyway, just try. Um, Amit, did you get the answer?
No,
Harish,
sir,
yeah. Amit, yeah, yeah.
Sir,
not yet, sir. I can't visualize, sir.
Okay, okay, okay. So, okay. This is the problem with visualization only. I mean, if you can visualize this problem, then you can easily tell the answer. You don't have to even solve this. Okay. So should I wait for 1 2 minutes? You guys want to try, or will I go to the solution? Or I'll. Who's this? I can't hear properly. Who was that? Am I audible?
Yes, sir.
Yes,
You are.
sir.
Am I audible, right? I'm audible, right?
Yes, sir.
Yeah, yeah. So who was that? Last, could not hear properly. Oh, someone was saying something. Okay. So what is the answer? Please tell anyone apart from the Sejal. So 0 degree, 90 degree, 180 degree, 270 degree, anything? Okay. Let me ask people first. What's the difficulty here? First, I want to know what's the difficulty. So Harish, can you just tell me what's the problem here? I mean, you could not understand the problem, or what's the difficulty?
sorry, sir. Today is power cut, so I am not trying.
Oh, okay, okay. Oh, then it's
Sorry, sir.
fine. Then it's fine. Okay, no problem, no issues. So, okay, Sejal has answered already. Amit, acha,
Yeah.
let me yeah, yeah, Amit.
Sir, actually, I was trying a mathematical physics solution, so I'm
Ha ha.
right now jumping from this to that, so I can't visualize at the moment.
Okay. Okay. Let me help you
सर
guys. So yeah, Harish.
सर मुझे कुछ आइडिया आ रहा है, मतलब ये कंडक्टिंग वायर है, ठीक है? तो इसमें जो मैग्नेटिक फील्ड की डायरेक्शन होगी वो फाई कैप डायरेक्शन में होगी, ठीक है? और इलेक्ट्रिक फील्ड की
मैग्नेटिक फील्ड का
डायरेक्शन जेड
डायरेक्शन फाई कैप डायरेक्शन में क्यों? दिस इज अ
अजीमुथल डायरेक्शन।
electromagnetic wave, right? So doesn't this is not current carrying loop. This is only, so this is basically only a conducting wire, circular loop, and on which the electromagnetic wave is incident.
अच्छा
This is not a current carrying
ठीक।
loop. Even
ओके
though if
ओके
it is a current carrying loop, the magnetic field direction will be along the axis, right? Not along the normal to the loop, not along the phi cap, right? Even though that is also wrong, right? Okay, so let me ask some questions before going to the solution. Okay, so let assume the loop is in the xy plane. Okay, so what should be the magnetic field direction so that the flux is maximum? Can you please tell me? Anyone? Consider the xyz, I mean Cartesian coordinate system, and your current circular loop is in the xy plane, and electromagnetic wave is incident on the loop. So what should be the magnetic field direction of the electromagnetic wave so that your flux will be maximum?
Z direction.
Yes, z direction, right? That's correct. So that is
सर
along the
परपेंडिकुलर।
normal to the plane. That is along the normal to
यस
the
सर।
plane, right? Okay,
यस
fine. So now what is the induced EMF formula? Please tell me. So if you're,
Minus phi by dt.
yes, minus d phi dt. So phi is here your magnetic flux, right? So here what is changing? The area is constant. So flux is basically your magnetic field times is the area of the loop, right? That will give the total magnetic flux through the circular loop, right? So here area is constant, loop size is not changing, or the area is not changing, but your magnetic field is varying with time because it's a plane electromagnetic wave. So the time variation of magnetic field will give the time varying flux. So basically, if your flux is maximum, when your flux will be maximum, then your EMF will be maximum, right?
सर
हाँ, yeah.
जो सर्कुलर लूप है उसको कौन सी प्लेन में रख रहे हैं?
Anything I am considering in XY plane doesn't matter.
सर एक्स वाई प्लेन में तो जो मैक्सिमम होगा वो जेड डायरेक्शन में होना चाहिए ना सर?
हाँ, B field should be along the Z direction. That I am saying, na? That someone has already answered. I asked that question. So magnetic field should be the magnetic field of the electromagnetic wave should be along Z direction. So B dot B times A, the area of the loop, times cos theta. Theta is the angle between your magnetic field and normal to the loop. So if theta is 0, then your flux is maximum, right? That means your magnetic field is along the normal to the plane. You got it, right? Is it understandable, or I am not getting any response? Harish?
Yes, I. Yeah.
Yeah. So, okay. Now, so if your magnetic field is along z direction, so what should be your electric field direction? Can you please tell me? This is the TEM, transverse electromagnetic wave. Sorry?
Normal to Z direction.
Normal to z direction. So what should be the, in which plane or in which direction it should be? That should be
In
in
the
xy plane, right?
Yes.
Okay. So if we,
सर जैसे
yeah,
सर ये कंडक्टिंग वायर है,
yeah,
सर्कुलर कंडक्टिंग वायर है,
हाँ,
तो जो कंडक्टर होता है उसके इलेक्ट्रिक फील्ड है ना वो उसके परपेंडिकुलर होता है।
प्लीज रिपीट करो फिर से, क्या बोल रहे हैं?
सर कंडक्टर होता है ना, मतलब
हाँ
कोई भी
हाँ,
कंडक्टर, उसका जो इलेक्ट्रिक फील्ड है वो उसके परपेंडिकुलर होता है।
perpendicular to what? Plane of the loop.
प्लेन प्लेन यस,
Why
प्लेन
it
ऑफ
should be
परपेंडिकुलर।
perpendicular to the plane of the loop? I didn't get your point. Can you please explain your statement? Why it should be?
सर मैंने ये पढ़ा है कि जैसे मतलब कोई भी प्लेन है, जैसे प्लेट है, ठीक है, कंडक्टिंग प्लेट है, तो उसका जो इलेक्ट्रिक फील्ड होगा ना सर, वो एंड कैप डायरेक्शन में होगा, दैट इज अ
No,
परपेंडिकुलर टू
that
द
is
प्लेन.
you are saying about the charged conducting surface, right? This is a different case. This is not a charged or current carrying loop. This is a normal conducting loop. Here it is given conducting wire because induced EMF will generate a current here. That's why. Otherwise, there is no reason to, I mean, consider that. I mean, you are saying that there is charge or current. That there is nothing said in this question, right? That is not relevant to our question, I think. Maybe I am not getting your point, but in this case, that is not relevant.
Okay, okay. Sir, I have another doubt related to this. सर जैसे कंडक्टिंग प्लेन होता है ना, उसके कारण हमें जो इलेक्ट्रिक फील्ड मिलता है वो सिग्मा अपॉन एप्सिलॉन नॉट मिलता है, ठीक है?
That I understand. Yeah, yeah.
ओके, और जो नॉन कंडक्टिंग होता है उसके कारण सिग्मा अपॉन 2 एप्सिलॉन नॉट मिलता है, ऐसा क्यों सर? मतलब कई लोगों से पूछ चुका हूँ ये बात.
Okay. Can we discuss it later? This is a different question you are asking. Can we
Yes,
discuss
yes,
it later?
you can discuss later it
Yeah.
to
Let me
not,
finish this.
yeah, okay.
Let us focus
yeah.
on this question first. Okay.
Okay.
Yeah. So, okay. So, so electric field should be in the XY plane, right?
Yes, sir.
Okay, fine. So, what should be the pointing vector direction then? Can
E
you
cross B.
E cross B direction? So, what should be the direction? I mean, if you know
Why?
your E vector is in the XY plane and B vector is along Z direction, so what should be the direction of E cross B?
Along radial direction.
Yes, that is in the XY plane, right?
Yes.
Not radial direction. It should lie in the XY plane.
Again in the XY plane,
XY
but
plane.
normal to the
Electric
E
field and
direction.
B vector also as well, right? It should be perpendicular to the E field and B field, and so your B is along Z direction, E is in the XY plane. So E cross B will also be in the XY plane, but normal to the electric field, right? Am I clear to you?
Yes,
Right?
sir.
Okay. So if your E cross B is along, your pointing vector is along in the XY plane, and your B vector is in the Z direction, and that is along the normal to the plane, right? You got the condition for the maximum flux or maximum induced EMF from that. So what should be the answer there?
90.
Yes. So the answer should be 90. So you don't have to do nothing. You just have to visualize what should be the direction. Yeah. Okay. So let me go to the solution, formal solution. Anyway, I think people something has some forgotten or something concept. So I'll be discussing from the basics. So this thing we know, according to Faraday's law of electromagnetic induction, the induced EMF is your, I mean, E equals to minus d phi b dt. So here I am considering a circular loop of radius a, and this is a very small loop that is very small compared to your incident wavelength of the electromagnetic wave. Now let us consider the magnetic field of the electromagnetic wave is making an angle theta with the normal to the loop. So here your normal to the loop is along z direction, that is n cap. I am denoting it by n cap. So now this d phi b dt, here phi b is the magnetic flux, so it can be written as minus d dt surface integral of b dot ds, where ds is the your elementary surface area of the loop. So you can just take it inside, you can write it as your induced EMF minus of surface integral of del b del t. Now ds vector is along the n cap, right? So here you will get a dot product with del b del t dot n cap. Okay, so del b del t will have the same direction of b vector. Now b and n cap is making an angle theta, so you can write in the, so you can do the dot product and you can get this del b del t times ds cos theta. Okay, so theta is the angle between your b and normal to the plane, that is n cap. Okay, so I think this was, you can recapitulate this thing. Now to generate the maximum induced electrical signal or EMF, the angle theta should be either 0 degree or 180 degree. I am considering only the magnitude, not the sign of the induced EMF. So in this case, if it is 0 degree, then it is, I mean, will be minus sign will sustain, and if it is 180 degree, it will be plus. So I am considering the magnitude here. So either it will be along the your n cap or anti-parallel to the n cap. Okay. Now, if B is along parallel or anti-parallel direction with the normal to the plane of the loop, your E vector should lie xy plane, because it is a TEM wave. Plane wave is a transverse electromagnetic wave, right? So your electric field should be perpendicular to the magnetic field. So it will be always in the xy plane. Up to this is clear, right? Any doubt about this? Okay, I think it's clear. Okay, now you know your Poynting vector is 1 by mu naught E cross B, that is along the propagation of the electromagnetic wave, that you know. So your now you just imagine your electric field vector is in the xy plane, B vector is along the n cap or z direction. So E cross B, so that will lie also in the xy plane. You can understand this, right? Because it has to be, because it has to be perpendicular with the B as well as E. So there is only one option, that it will be in the xy plane only. So your Poynting vector will be in the xy plane, that is in the plane of the loop. So hence you can easily say your S vector, that is the Poynting vector, is making 90 degree with the normal to the plane of the loop to generate a maximum induced EMF. So is the whole thing clear?
Yes, sir.
Okay, okay. So I have one
Sir?
thing. Yeah.
Sir, what is the significance of that A less than lambda?
Yeah. So here actually one thing. So what I understand from this question. So basically, if your size of the loop is very small, I mean corresponding to the your I mean then the lambda. So then the phase of the electromagnetic wave. So because phase, how we define 2 pi by lambda time path difference, right? So phase change within the your conducting loop will not change much. So you can consider it as constant. So your phase is not time I mean at a particular time it is not spatially varying. So that's the significance here it is given. Other than that I can't find anything. So basically it will be uniform. Otherwise the EMF will be spatial space coordinate dependent. That's the thing I think it is given. Am I able to explain this, or
Sir, repeat please.
yeah? So basically, for an electromagnetic wave, when it propagates, it acquires a phase because of the distance traversed by this electromagnetic wave, right? So that is given by 2 pi by lambda times the path covered by the electromagnetic wave. Now, if your loop radius is very, I mean compared to lambda or very bigger than lambda, then your 2 pi by lambda times your path difference, that will be significant, right? But here the size is A is very less than lambda. So your phase difference between 2 points will be in the order of 2 pi by lambda times A. And now A is very less than lambda. So your phase difference is negligible between 2 points. And that will not make any difference in the induced EMF across the conducting wire. So it will be uniform. Is it clear?
Okay.
Yeah. That's the only thing. You don't
Sir,
have to.
if it is not uniform, will it make any difference in the answer?
Okay, let me think. So if it is not, then your magnetic field. Okay. Then it will acquire a phase. I don't think so, because it is only you have to use a time derivative, right? So if you acquire phase, there will be phase term which will be spatially dependent. and if you take the time derivative, then I don't think so there that will make a difference. I don't know why. I mean why it is given, but I don't think that will make some difference in this particular question, at least. I don't think so, because you are taking only the time derivative, not any space derivative is coming in this case, right? I don't think so. Anyone?
Also, maybe it
Yeah,
could be because
yeah.
at some point in space, B is directed along the, say, towards the right, I
Mm-hmm.
mean, into the loop, and at another point inside the loop itself, if the loop is big enough, it is
Mm-hmm.
directed
Mm-hmm.
opposite to that direction, so to
Yes.
the left.
Yes.
So
Yes.
probably that will just cancel out, and there will be no B there will be no flux at all, and hence no. Uh,
Oh, you are asking about the magnitude of the EMF, right? So you are talking
yes,
about
sir.
the, yeah, that will definitely affect. That's the thing, that you are right. So I am just talking about the direction of the Poynting vector. That will not make any difference. Otherwise, it will be zero, or there will be some. I mean, yeah, it may vary because with the size of the loop, right? That's the thing.
Yes, sir. So if the
Bec-
EMF itself is zero, then this question will not hold its
yeah,
no.
yeah, yeah, yeah. That's the thing. But I think, yeah, you are correct. You are Sejal, right?
Yes, sir.
Yeah, yeah, that's a good point. Yeah, yeah,
Yes, sir.
that's a good point. Anyway, along if you consider direction, that will not make any difference. Only thing, if it is not zero, right? Yeah.
Yes.
So anything else?
Sir, if you consider Lenz's law, then it will oppose the
Hmm.
applied magnetic field.
Hmm. It will oppose.
And there will be a phase difference of pi by 2 between the applied and the one which is
Pi,
generated.
not pi by 2. It should be pi, right? Because it will try to cancel out the magnetic field in the opposite direction,
Mhm.
right?
Mhm.
So yeah, that is then, though, you have to consider the whole picture. Then you can find the because magnetic field will be reduced because of the induced EMF, right? The actual magnetic field there. But I don't think so. Either it will be along the z cap direction or along the minus z cap direction. Other than that, it is not possible, right? I can you tell me if the question is different from?
So if it is large enough, then as we move towards the center of the loop, then it will be zero, I guess.
It will be zero. What should be zero?
So the magnitude.
Magnitude should be zero.
I
No,
mean,
actually, what Sejal pointed out, that the thing, that is a good point, because see, if you consider your radius is say lambda by 2, your is lambda by 2, okay. So what should be the, so if you consider two points connected by a diameter, so then what should be the phase difference between magnetic field at that 2 point? That should be pi, right?
yes, sir.
So the direction will be opposite at that 2 point, right?
Yeah.
In that condition, your magnetic field, so half of the loop will have plus z cap direction magnetic field, and half of the loop will have minus z cap magnetic field, right? Because they will they are conjugate points too. If you consider 2 points connected by a diameter, then in that case your flux will be zero, even though you have finite magnetic field, right?
Yes, sir.
So in that case, so that's a good point. I think because of that, this is given. Yeah, now it's totally clear to me now. Thanks, Ajal.
Welcome, sir.
Yeah. So will I go to the next question?
Sir,
Yeah, yeah.
what I was thinking that if by applying
Hmm.
if just by keeping a loop in the wave,
Hmm.
its amplitude will decrease in means if you are applying in a positive x direction, say, and
Hmm.
the loop is kept at origin, and
Hmm.
at x equal to some distance, the uh, what do you say, the intensity of the electromagnetic wave will directly decrease.
This is a plane wave, so it doesn't matter. It doesn't will not depend on the amplitude of the electric field or magnetic field will not depend on the your position, right? It's a plane wave. I didn't get your point. I mean, why it should decrease with the distance? It's not spherical wave.
No, sir. What
Yeah.
I was saying that
Hmm.
if an electric if EMF is generated in the loop,
Oh, okay, okay.
uh,
Yeah. Hmm.
then it will produce a negative effect of the
Right.
applied magnetic field.
Mm-hmm.
So what we can say that the resultant amplitude of the wave will decrease.
Yeah. That's
So,
obvious. That is obvious. The magnetic field intensity will also be decreased, and also as well as electric field. Right.
so, sir, can we assume that if we just place something in the electromagnetic wave like a loop or something, then its intensity will decrease
Electromagnetic loop.
after certain. No, sir. If just like in question, whatever, if a loop is placed, conducting loop, and the and if you apply electromagnetic wave, then its intensity will decrease after we come out from the loop, means at any distance x equal to a.
It will decrease. It will decrease at the plane of the loop. Then at a distance that far away from the loop, that will be again a plane electromagnetic wave. So yeah, at the plane of the loop, it will be decreased. Where the interaction with the loop will happen, then in that region it will decrease. And you are saying that that will be spatial dependent, because the magnetic field because of the induced EMF will be, I mean, decrease as we go far away from the loop, right? You are trying to say that?
No, sir. I'm just saying that if we come out of the loop and say the loop is of radius r, then at any distance r greater than a, we will get a lesser intensity of the electromagnetic wave, whichever.
That you will get. That you will get. But you are asking about the spatial variation, right? I mean, it will depend on position at r greater than a or not, right? I mean, I am wrong. I could not understand your question properly. But it will decrease for sure. It will decrease for sure.
Okay. Okay.
Yeah. Okay. So I'll go to the next question. Any doubts? Anything else? Or will I proceed to the next question? Okay, I think no one has question. Okay, so next question. Okay, this is also from GATE Physics paper 2020. This is a MCQ type question having 1 mark. This is also from electromagnetic theory. Now the question is, if your E field, that is electric field, and your magnetic field B vector, so it is given that E dot B is option A, odd under parity and even under time reversal. Option B is even under parity and odd under time reversal. Option C, odd under parity and odd under time reversal. And last option, option D, even under parity and even under time reversal. So you have to choose the correct option. This is a very straightforward question. First, okay, let me ask people, what is parity and what is time reversal? Can anyone say? Anyone can try? What is parity operation? You must have read in quantum mechanics.
Just we replace the position vector by negative of that. Means
Yes.
x by minus x.
Yes. So when it will be odd under parity operation, when it will be even under parity operation on some
If
function.
f of x is minus of f of minus x.
Okay. Then it will be odd or even?
Odd.
Odd. Okay. And it will be even if?
It is equal to f of minus x.
Okay. That's correct. And what is time reversal operation? Can anyone say? Oh, so who answered the last?
T going to minus D.
Yeah, this is Sajal, right?
Yes, sir.
Who was the last guy? I forgot to ask the name.
So Amit.
Amit. Okay. Okay. Fine. So you know you have the idea about parity operation and time reversal operation, right? So now you have to. So what you have to do here? First, you have to know how electric field behaves in under parity operation and time reversal operation, and be same thing for magnetic field, right? If you just know that, then you can tell what will happen to the E dot B. So you have to know individually for E and B vector. So can anyone say how to comment on that?
So we can just see whether it is a scalar vector or pseudo scalar or pseudo vector.
Right.
Then we
Yes.
can just get the answer.
So what should be the answer? Then can you please explain from that?
I didn't remember.
Okay.
I forgot
even though
what
it
it.
is even though it is pseudo scalar or axial vector, you are talking about the magnetic field is a pseudo vector or axial vector, so that behaves differently in the parity operation, right, or also in time reverse operation than the usual polar vector, right? That there is some difference because B vector is basically a cross product of two things, that is from Biot-Savart law, right? So cross product is eventually give a axial vector or your pseudo vector. That's the thing. From that aspect also, if you can understand from that aspect, that is good, but I will explain it slightly different. Okay, so okay, anyway, I want you guys to try this. If you can try that will be very good. Otherwise I can go to the solution. I have to explain these things. So anyone want to try or knows about this?
So what is E? E is
Electric field
pseudo
vector.
vector.
Electric field is a polar vector because that has a particular direction as well as starting point, ending point, right? Because if you have two plates, electric field will be confined within that two plates, right? So you have starting point and ending point as well as particular direction. So basically, polar vector is related to the translational motion of a body or translational vector, but magnetic field is a pseudo vector or axial vector. So basically your pseudo vector is related to a rotation of a body. It doesn't have any starting point. You can only specify the direction of the vector, but you can't specify a starting point or ending point, right? For magnetic field, you can't say it is starting from here and it is ending from here if it is not a magnet, first of all. Yeah.
So I'll try.
Please try, take your time, and I want you to try. Okay, let me give you a hint. Okay, I mean how I will solve I have solved this, or I will try to explain this problem. So think about the Lorentz force. Okay, because in case of force, you can easily identify what will happen under parity operation time reverse operation, because force is simply your mass times acceleration, that is d squared x dt square, or in 3 dimension d2 r vector dt square. So in that case you find how it behaves the force, and then you just compare the right hand side, and you know the Lorentz force expression, right? That is q e plus q v cross b. Here v is the velocity, so you know how it behaves in the under the parity operation time is a v also. From that you can comment about the e and b. You can find the how it will change under parity and time reverse operation. Is my hint is clear, or I will repeat again?
Yes, it is clear, sir.
Okay, so the key point is think about the Lorentz force expression and try to apply the parity and time reversal operation on the both side and see how it changes. So from that you can comment on the E field and B field. If you know the how it changes individually for E field and B field, then you can easily comment E dot B because it's a scalar product, right? Amit, is the question is clear? Harish?
Yeah.
Harish?
Yes, sir.
Okay. So are you trying, or I have given the actual hint. So if you can find the, if you can understand the hint properly, then you can easily answer this. That's the thing I will use in the solution. Okay, take 2-3 minutes and try to solve answer this, or you can guess also. In no, don't worry if you are wrong.
Sir,
Hmm.
uh, so you said that we have to apply these two operations on both sides. So if we apply
Sorry,
to the
sorry.
fourth formula,
Can you please repeat? Your voice was not clear. Can you please repeat, Sejal?
am I audible now, sir?
Yeah. You are audible.
Okay. So if we apply these two operations on the left hand side, and you said left hand side is just the force, which is d square x by dt square. So it should be a pseudo vector then, right? In pseudo vector in
Force
terms
is
of
a
parity.
Sir,
who,
see,
which should be pseudo vector E dot B, you are saying?
No, the force itself.
Force is a polar vector because it has particular direction, starting point.
But sir, if we look at d square x by dt square, then if x goes to minus x, it will be negative.
Huh? So how does it matter? I mean, what's
Mm,
the issue here regarding the polar or axial vector?
so under parity, will it not be an odd parity vector, sir?
No. It is not the axial vector. It doesn't matter if it is axial or polar vector. So it may change. Some polar vector may change under parity operation. So it will definitely change, because if you take the mirror deflection. So what is the parity operation basically? Mirror deflection of that your system, right? So your force is along, basically polar vector changes its sign under parity operation, because you are changing your coordinate system from right to left here, right?
Yes,
So
sir.
but its magnitude will not change. That's for sure. Yeah, but force is a polar vector.
sir,
Yeah.
so odd parity and odd under time reversal.
Can you please explain your answer just in short?
So because
Yeah.
E dot B will be a vector, polar vector, so it should have odd parity and
Why e dot b should be polar vector? It's a scalar quantity.
oh sorry,
Okay.
it should be a scalar.
Okay.
So oh okay, then it should have even parity, I guess. Okay, I need to check again.
Just check.
Sir,
Just try with the Lorentz force equation. I am again saying again and again. Don't go with the scalar or vector. It will be
sir,
confusing. Yeah.
sir, I am not trying
Who
because
are
I
you?
am my mind is not working today.
Who?
But I have remembered this one answer
Okay.
because I solved before 1 year.
Okay. You can tell me the answer.
Amit is saying right answer. She is the correct option. Amit is saying right.
Okay. But okay. So, acha. I will not say what's the correct answer now, because without explanation, it is not okay to comment on that. Okay, so I want you to understand it properly. So that if something is else is asked regarding this question, you can answer it properly if you understand this. Okay, so acha, can you even say what will happen to electric field under parity operation? Let me start from the scratch.
सर अभी याद सर याद नहीं आ रहा कुछ भी
That's why I'm
because I
saying
am
just write the
It
Lorentz
will
force
be
equation. Yeah.
so it will be odd under parity.
Sorry.
It will be odd under parity, the electric field.
Why it should be? Can you explain from the Lorentz force equation?
So the electric field only.
Yeah, only electric field plus first you say you comment on the electric field, then I will ask about the magnetic field. Okay, so will I go to the solution? I mean, people have lots of confusion. Okay, so I think it will
Yes,
be
sir.
clear when I will explain this. So it will be completely clear this thing. Okay.
Please explain.
Yeah, okay. So I will give a brief introduction. I think you know this thing, but that is not maybe too much relevant. I will not explain here polar vector, axial vector. You will find it, I mean, this thing in the mathematical physics book. So your electric field vector is a polar vector, right? Your magnetic field vector is a axial vector or pseudo vector. Now I will explain what is parity operation, what is time reversal operation. So parity operation or transformation is the space inversion or deflection. That is a mirror image of your vector. So okay, it means flip in the sign of spatial coordinates. So if you have your position vector r, and if you operate your parity operator p cap, let us denote it as p cap, then your r vector, position vector, will become minus r vector. So if you operate your p cap on some function, that is a function on a function, that function is dependent on the position, then you have to just change the sign of the position, minus r, right? So this is the parity operation simply. And your time reversal operation, it means the operation of replacing the time with its negative value, so that it indicates a phenomena in which time runs in backward direction. All motions are reverse, so we are going in a backward direction. So if your time t cap is the time reversal operator, so you have to replace the t by minus t, right? So this is a simple thing. Now we will apply this concept in the case of electric field and magnetic field here in our question. Okay. Now I will explain. It can be explained many more ways, so but I feel it convenient to explain using Lorentz force equation. Consider a particle of charge q moving with a velocity v in an electric field and magnetic field p experiences a force, that is the Lorentz force, and that is given by q times E plus v cross b. Now you can write the force as m times your acceleration, that is d2r dt2, right? Now if you just operate p cap operator on this force on the left side, so your r will become minus r. So f will now become as a function of minus r. You just replace the r by minus r, so it will become minus m d2r dt2, right? So here it is getting minus f. So f will flip its sign, so it is odd under parity operation, your force, and under time reversal your force it will be d of minus t square. So basically it is d dt of dx dr dt. So there will be 2 times d dt. I mean d dt will dt will come 2 times. So by that minus minus will cancel out. So essentially it will not change its sign under time reversal, right? So now we have the information about the left hand side. So how the left hand side will change, the right hand side has to be changed like that, right? So you know, we have already discussed f will change its sign under parity operation, but time reversal it will not change its sign. Now Lorentz force is your this, so we will divide it into two parts. First is electrical part and second thing is magnetic part. And one thing, charge doesn't change its sign under parity and time reversal. It's a physical quantity or scalar quantity, right? So it will not change its sign in this case. Also mass as well. Okay, so under parity operation, f will change its sign. So now f is q times e. So if f is changing its sign, but q remains unchanged, so e has to change its sign, because right hand side has to change in the same way as f is changing. So is it clear? So e will flip its sign. So is it clear?
Yes, sir.
Yes,
Okay,
sir.
okay. So you know E has odd parity. E is odd under parity operation, right? So now we'll find the what will happen in case of magnetic field. So for that we have to consider this expression. Now this whole expression will change its sign, because f is changing its sign, right, under parity operation. Now v is dr dt. Now under parity operation, this v will get minus v, because r, if you replace r by minus r here. But under time reversal, it is also changing its sign, because you will replace t by minus t. So v will change to minus v. So q this term under parity operation will change its sign, because f is changing its sign, right? Now here v is changing its sign, so basically this minus 1 sign will come from the v itself. So b should not change its sign, otherwise it will be positive, right, if b is also changing its sign. So b should not change its sign, so b will remain unchanged. Is it clear? Or
Yes, sir.
okay, can you remember that thing what you have studied earlier?
Not, sir.
Okay.
Today is very interesting thing.
Okay, fine. So we have learned how electric field and magnetic field is changing under parity operation. So what will happen to electric field? It will change sign or not?
Change.
It will change. So it is odd under parity operation, but magnetic field is even under parity operation, because B.
Yes, sir.
Someone is saying something?
Yes, sir. Clear, sir.
Okay. So this is the conclusion up to this discussion. So E will change its sign. This is odd under parity operation. Magnetic field is even under parity operation. Okay. Now we'll go to the time reversal. There's the same way we'll go with this. So under time reversal, F will not change its sign. So the same thing will happen to E. E will not change its sign under time reversal operation. So it will be even under time reversal operation, electric field. But in case of time reversal operation, this V vector will change its sign, right? But if will not change its sign, so B has to has as minus sign under time reversal operation. So minus minus will give plus. So effectively Q into Q times V cross B will not change its sign under time reversal operation. So B should change its sign under time reversal operation. Is that clear or in confusion?
सर वी मतलब माइनस वी है और बी मतलब बी भी चेंज होता है सर, कुछ समझ में नहीं आया.
अच्छा, समझ में नहीं आया. ओके, सो सी, सो तुम्हारा लेफ्ट हैंड साइड जैसे चेंज होगा, राइट हैंड साइड हैज टू बी चेंज लाइक दैट, राइट?
यस सर, यस.
Under time reversal, if is not changing its sign, so it remains the same, right?
यस सर.
That I have discussed already in the previous slide, I think. This thing I have discussed already, right?
यस यस.
Okay, so I am using that information here. So this part Q times V cross B, this term, this magnetic term will not change its sign. The total term Q into Q times V cross B, right?
Yes, 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 yes.
Now V is changing its sign itself, right? Under time reversal operation.
Yes.
But how will it happen if this quantity will be positive? Only if your magnetic field is changing its sign, so that your minus minus will give positive, right?
Yes. Yes sir.
So
सर वी
magnetic,
दोनों में चेंज करता है साइन, है ना, टाइम रिवर्सल और
yes,
पैरिटी में.
yes,
यस यस यस, दैट इज द पॉइंट.
yes. So if you know this information while reading the electromagnetic theory, then you can easily answer it. You don't have to go with this also. You just remember this information. Electric field changes its sign under parity operation, but doesn't change its sign under time reversal. And in case of parity operation, and in case of magnetic field, it is just ulta, right? See here, under parity operation, E is changing its sign, but under time reversal operation, this magnetic field is changing its sign, right?
या.
Okay. So if you know this, then you can easily solve this. So you have the information about the electric field and magnetic field here under parity operation, time reversal operation. Now we apply parity operator on E dot B. Now under parity operation, your electric field will change its sign, but magnetic field will not change. Effectively, we will get minus E dot product with B. So effectively, you will get minus E dot B. So it is changing its sign, right?
सर
Yeah.
एक मिनट सर, यहाँ पे ई वेक्टर डॉट बी वेक्टर की बजाय हमें पॉइंटिंग वेक्टर के बारे में पूछता, तब क्या होता सर?
Okay. Pointing vector. Okay. E cross B.
यस सर, यस.
That will also. Okay. Let me understand that question.
Or
That will also I think change its sign, because pointing vector is along your k vector, right? If you propagation of direction will be reversed under mirror deflection. Any someone wants to say something?
So it will have the same effect.
Yeah, it will have the same thing, because you have to just apply on the both the quantity. Doesn't, I mean, it will matter obviously, some in some cases if it is dot product or cross product, but uh, in this case it will not, it will behave as the same, E cross B or E dot B.
We will get same result, right?
Yes.
Okay.
Yeah. So under time reversal, the same thing will happen, but in this case, B vector will change its sign. So effectively, we get minus E dot B. So it is odd, right? Odd under time reversal operation. So E dot B will change its sign under parity operation as well as time reversal operation. So it is odd under parity operation, odd under time reversal operation. Is it clear?
Yes, sir.
Okay. So your option C is correct one, right?
Yeah.
Okay, so now I'll go to some questions asked by some students, Amit and Harish. So I'll go with the first question. So this question was, I think Harish, you told me 34 and 35, right?
Yes.
So I will first explain the 35. So I want you to guys you to try this question. This is very good question. This was sent by Harish. So I will read the question first. The spin orbit introduction term of an electron moving in a central field is written as. Okay. Any doubt in the last question? I forgot to ask. Last question was clear, right, to everyone?
Yes, sir, clear.
Okay, fine.
So,
Yeah.
so if we want to find whether it changes or doesn't change sign under time reversal, electric field for electric field, without using the Lorentz force, can we do that?
We can do that. We can do that. I have actually, when I was doing this, I was searching another method also. We can do that. So what happens? I tried to understand that thing in terms of applying the rules to pseudo vector. So how it behaves when your coordinate system is changing. Basically, under parity operation, you are changing your coordinate system, right? But the pseudo vector behaves differently than the polar vector in the from, I mean, you're changing your coordinate system from right to left. We can do that. You can see, but I have to understand more about these things. How the pseudo vector behaves when you're changing your coordinate system from right to left. We can do that, but I thought that will be a little bit difficult to explain in this case. If you understand, you
Sir,
can share with us. I mean, I don't understand much that thing.
so
Yeah.
right now I didn't start with B. I was just thinking about E first. That
Okay.
E can be written as KQ by R square times R cap. So from there we are directly getting that it's odd under parity. But
Yes.
how to write E in terms of time?
Okay.
Should we write the plane wave equation solution? That will work, or
Let me think now if I can answer. Okay. So under time reversal, okay. Hmm. If you consider the electrostatic force E field that we are talking, uh, in that case, I don't know how to visualize if we go into backward in the time direction. It should not change, right? Because with time, it will be in the same direction for E field. That I can only say from my intuition, right? I mean, I can't imagine something else. Also, if time reversal is related to rotation, if you rotate your just let me think. If you rotate your body, the electric field vector will be same. It doesn't matter if you consider sphere, then it will be spherically symmetric, so it will not matter. But if you consider mm, I don't know at this moment how to explain from that aspect. Sorry. I
and
mean,
so if we
yeah.
talk about this time reversal of magnetic field intuitively without any formulae, how do we can we even imagine like it's odd under time reversal? So at this moment it's in one direction and somewhere in the past it was in the other direction.
Yeah. So, okay. that's a little bit imaginary thing going to the past in case. So yeah.
So electric field can be imagined like a vector. So if we consider it as a just as a vector, simple vector. So if we go forward in time and then come back, the vector won't change.
Yes, it will not change. It doesn't
So this way
yeah.
we can say that it is not odd under time reversal.
Okay. Yeah. Electric in case of electric field, it can be said. But how will you say in case of magnetic field in with that concept? Uh, if it is time reverse, so then minus t. Okay. Okay, I'll check this thing properly. Okay, I have explained it more mathematically. I also have to understand this thing more physically, how it happens. Okay, maybe I can
Yes, sir,
Sejal, we
sure.
can discuss in the next class. I'll check this. Okay.
Okay, sir.
Okay. Yeah, also, you please check if you have any idea to you can share in the next class.
Yes, sir, I'll try.
Yeah, please. Okay. So I'm going to the next question. So this question is the spin orbit interaction term of an electron moving in a central field is written as if as a function of r times L dot s. So this is a L-S coupling term where r is the radial distance of the electron from the origin. Now, if an electron moves inside a uniformly charged sphere, then which will be true? Option A is if as a function of r is constant. Option B is if as a function of r is proportional to 1 by r. If r is proportional to 1 by r square, if r is proportional to 1 by r. Okay. So is the question, I think question is very straightforward. So let me know if you have any doubt about the question first. You know about central force field, right? It only depends on the distance from your origin. Doesn't matter in which direction you are talking about, right?
Yes, sir.
Okay, so that's the thing. So you can write your force, central force, as a function of position times r cap
Yes,
vector,
sir.
right? So that's the thing. So here one thing you have to know, because there is some if you have read about the LS coupling, so how it electron will behave in a generalized central field, that if you know the expression, then you can easily solve this problem. You can comment on the answer. Otherwise it will be a little bit difficult. So if someone knows what will be the spin orbit interaction term in case of potential V as a function of r, does anyone know? You have solved it in the case of
I need
hydrogen
to
atom
check that,
problem.
sir.
Sorry.
I need to check that.
You can check and you can tell me now. You can check in the Google also. You can check in your book also. Please let me know. I mean, I had to see that formula. Obviously, I forgot, but it is in your textbook. Uh, if you have to remember that thing, otherwise it will be difficult here. So, you want me to go to the solution part, or you want to try?
It's D.
It is option D.
Yes, sir.
Why it should be? Can you please explain?
So the FR is inversely proportional to R cube.
Fr is inversely proportional to r cube. That is true for hydrogen atom problem. But here it is asked an electron moves inside a uniformly charged sphere. Right?
Okay.
The potential or electric field, how can anyone say how the electric field will depend on position or r in case of inside the uniformly charged sphere? What's the expression for the electric field? Can anyone say? Suppose you have total charge q or charge density rho for the uniformly
Rho r
charged.
by 3 epsilon naught.
Uh-huh.
Rho r by 3 epsilon naught.
So it, 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 varies as proportional to r, right?
3 epsilon naught. 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 Yes, sir.
Who is that? Can you please tell your name?
Prajwal.
Acha, Project. Okay. So it is not the same as hydrogen atom problem, right, Amit?
Yes, sir.
So your answer will be difficult. Will be different in this case.
Yes, it will change.
It will be 1 by r cube in case of hydrogen atom problem. That's true. But in case of just think, so okay, I think I should explain the answer, because without the expression, knowing the general expression, I think it will be difficult for you to answer this question. Okay, anyway, if you know the expression, then you can easily solve this problem, and I think I mean, it will be helpful to you by knowing this. Okay, so the spin orbit interaction term is given by this, right? Now you can find what I am saying, the formula. I am not deriving this. You can find this in the textbook, in Sakurai, or I think in Gasolis is also there. I forgot this thing, but in Sakurai I think you will get this. So for a general potential, yeah,
Sir, this is from atomic physics or quantum mechanics?
you can you will find in the both the thing. This is also part of atomic physics. LS where you will get the LS coupling, you will find this thing. So this is a generalized. So when you will apply the perturbation, you are applying the 1 by r square electric field, right? Instead of that, if you apply the general potential here, you will get this expression. Only thing is that. Basically, LS term is coming from the perturbation, right? I think second order perturbation. I think so, because if you relativistic, obviously you have to consider the relativistic thing, otherwise you can't get the spin orbit coupling. That is root over p square c square plus m square c to the 4, right? If you expand that thing from that, also you are getting a term, I mean higher order term in the energy, kinetic energy term, right? From that, the Ellis coupling term can be explained. I will not go into details, because you will find this thing in the textbook. If you have any kind of doubts, you can just mail me. I will share the PDF. Okay. Uh, is it someone is? Can someone respond? Am I audible? Yes.
Yes, sir, you
Yes,
are.
sir.
Okay. So
Yes, sir. I think it will be found in Griffiths also and
ha,
Branson and Joshi also
yeah. I think
for
most of the
atomic.
books describes this generalized thing.
Yes,
Okay,
sir.
okay. So only thing you have to know this part, in case what will happen in case of generalized potential, because instead of the uniform charge, you may have given some potential form. In that case, what will happen? Then if you know this formula, this term 1 by r del v del r, that behaves like this, you can directly tell that answer. But without knowing this, it will be difficult to answer. Okay. Anyway, so here are two things. First, you have to remember this thing, that is the, for generalized potential, this LS term Hamiltonian will look like this. So the spatial dependent part is 1 by r times del v del r. So here this part is fr in your case. So your f as a function of r is proportional to 1 by r del v r del r, right? In this you have to remember first. Now that the one has already answered, we have to find the, I mean, this f as a function of r for an electron moves inside the uniform charge sphere. So I will not derive this thing. This is a very textbook thing. You can easily find the electric field and potential electric field using this Gauss law,
We aware
right?
from.
Yeah.
Yes, sir.
So I will not
Yes,
explain this thing. You know this expression for a uniformly charged sphere inside the uniformly charged
yes,
sphere,
yes, yes.
and you can find easily the potential, even though you don't have to find the potential in this case, uh, because here del v del r term is there, right? That will basically related to electric field, because your E is minus del v del r, right? Because it is a conservative electric field, electrostatic field, right? Is it clear?
Yes, sir.
Okay. So you know if you know your electric field, so it is proportional to R, right? So your del V del R is proportional to R, right?
Yes.
And here 1 by R you have, so it will cancel out, so it will be constant. Am I correct, Harish? This answer is option A.
Sir, I don't remember it.
You just check. If it is wrong, please let me know in the next class. Okay.
Yeah.
So this should be constant. And this is because if you can cross check, if you apply the your hydrogen atom problem, so what will happen? Your electric field is proportional to 1 by r square, right?
Yes.
So this will be 1 by r cube, and that is true. You know, the LS coupling term has the 1 by r cube term. So am I correct, Amit?
Yes, sir.
So you can cross check your answer. So if that is giving the correct answer, so this should be correct. Anyway, Harish, please confirm me in the next class. Okay.
Okay.
Okay, fine. So option A is correct for this. Now this question I have not, I'll explain this, but I have not solved this in my copy. This question is very easy according to me. So let me read the question first. I will explain verbally this question. This will not make any difference. Okay. Okay, so here a potential uh, barrier, I mean, is the schematic of a potential barrier. There are two potential barrier. One is finite potential barrier, one is infinite potential barrier at particular positions. Where here V naught is constant, it is given for particles of energy E less than V naught, incident on this barrier from the left. So particles incident on this barrier first. So which of the following schematic diagrams best represents the probability density, that is mod of psi x square, as a function of x? Okay, so there are 4 plots given. So first try yourself. How will you? You can just share your approach. Then I can understand. You get the correct answer on.
सर एक्स ग्रेटर देन बी के बाद एक्स ग्रेटर देन बी पे वेव फंक्शन कैसे होगा सर?
Sorry.
एक्स ग्रेटर देन बी के बाद मतलब बी के बाद वेव फंक्शन कैसे होगा सर?
It will not exist because it's the infinite potential. Wave function will be 0 in that case.
ओके.
Okay, so can anyone say which two options cannot happen in this case? First, cut out the options which is not possible here. C is not possible for sure, right? You know,
Sir, B is also,
B is also not possible. Why?
it is discontinuous at x equal to 0.
Exactly. So B is also not possible. So B is so I didn't expect he will tell this B. So I expected he will tell C and D. Okay, the B is also not possible by that logic. Okay, C is also not possible, and D is also not possible. Can you please tell me why?
Sir, I am confusing in A and D option.
A and D.
Sir, in D also the same reason, discontinuous at x equals b.
X equals to B, it is discontinuous. Yeah, that is also true. And one more thing, the magnitude is finite. Sorry.
सर एक्स इक्वल टू बी पे डिसकंटिन्यू कैसे मतलब?
No, because what Sejal is saying, because after x equals to b, it should be 0, right? Because it's an infinite potential. So it cannot drop suddenly. Okay.
Yes.
So it is not possible. Okay, and other than that also, what I thought, I mean, I thought in this way, it is not going to 0 because in the free space we have like a sin x, right? So it should go to 0 at some point, some x value. It is not going to 0 here. Also, I mean, I don't know here it is x, this is a 0 level axis or not. By that logic, it should be correct, obviously. So one thing you have to understand here, also one more thing, one more information you can get from this problem, that I will tell verbally now. But if you need a proper mathematical expression, I will share because I could not get time to write that. Okay, so what the thing is that your here your wave vector will be root over 2me by h cut square, right? You can get my point, right, from the Schrodinger equation?
Yes, sir.
Okay. Now, in this case, that will not be a plane wave. That will be e to the power minus beta x type wave, right? There's a decaying wave. It will be tunneling.
decaying.
And beta will be your sorry, beta will be your root over 2m by h square times v naught minus e. That's a simple thing from Schrodinger equation, right?
Yes.
Now, when you will find the wave function in this region, that will be wave vector, let's say k3 in the 3 region. This is the third region, okay, k3, okay. If you apply the continuity equation and as well as continuity equation between del psi del x between these two region, you will get a condition that is, I think that is k3 is I times beta. You will get that condition, okay. So your k3 magnitude will be now root over 2m by h car square times v naught minus e. So here k3 is different from k, right? You please check
Yes.
with the you please verify this thing, this condition. Just only thing you have to do, you have to solve the standard equation in this region. You have to equate at x equals to a both the wave function and del psi del x. That's the momentum matching, right? That is the thing for finite potential. So from that you will get the condition, you will get the information that your k3 wave vector in this vacuum region, that will be different from this, and that will be less than k3, right?
Yes, sir. Yes.
So your frequency of oscillation will now change. So if you just see this two diagram carefully, here the wavelength of your free particle will be now what will happen? It will be larger or small? Can anyone say?
Wave function.
Hmm?
Sir, repeat करना.
So what I am saying here, you know the k vector, that is root over 2me by h car square, right? Here your
Yes,
k3,
sir.
that wave vector in this region, it will be root over 2m by h car square times v naught minus e in magnitude, okay.
Yes, sir.
So what will be the wavelength?
Wavelength will increase.
Wavelength will increase, right?
Increase. Yes, yes, yes.
Wavelength will increase, right?
Yes.
So what can you see in this from these two picture?
A is
Can
correct.
you see any difference? So there are not only continuity difference, there is also difference in the magnitude of the wavelength also. Right, here it is same. You can I am not saying that it's same, but it seems to be same in this case, but it is little bit different. You can see.
Sir,
Yeah.
That's a very
मतलब
small difference, but it is.
But I think continuity is the best way to answer this question.
ये सर एक चीज और देखिए,
Okay.
देखना आप कि मान लीजिए ए ऑप्शन में ये डी वाला पार्ट है ना, डी ऑप्शन का एक्स लेस देन जीरो वाला पार्ट दे देता एक ऑप्शन में, तब मतलब वो राइट होता है या रॉन्ग होता है?
Sorry, can you please repeat?
सर डी वाले पार्ट में आइए आप, एक्स लेस देन जीरो से पहले का वे फंक्शन है ना,
हाँ,
वो
हाँ।
यहाँ पे ए वाले पार्ट में ड्रॉ कर देता,
हाँ.
तब ये ऑप्शन सही होता क्या ये?
It should go to 0, right? Because it should be a plane a sine kx type wave, so it should go to 0. Here this how the y-axis, it should is 0 or not, why it is starting, I am confused here, because if it is the 0 y in along the y-axis, then it should not be true, because some yeah, actually it can be, because if you add a constant wave with the plane wave, then it should happen. It should happen. So I should not tell it should be 0 directly. Okay, but you can
Sir,
add a constant, right?
yes.
Okay.
सर जैसे 1D बॉक्स है डीप, तो उसमें जो x इज इक्वल टू जीरो और x इज इक्वल टू ए पे वेव फंक्शन का जो स्लोप होगा वो कंटिन्यूस होगा या डिसकंटिन्यूस?
That is del psi del x you are asking, right?
यस सर.
Del psi del x, so there is a criteria. So del psi del x will be continuous for your finite potential. If your potential is infinite, then you can't tell that. You can't tell that your del psi del x should be because you have applied that concept in the delta function, I think. That is,
I think if potential is infinite, then slope will be discontinuous.
So will be discontinued. Yeah.
Yeah.
It should not be
I
continued.
am correct.
Yeah. You are correct.
Yeah. Okay.
Okay. Anything else in the regarding this question? This type of
So
question.
how can we?
Yeah.
So how can we say for sure that the wavelength must increase? It can also decrease. Depends upon whether V naught minus E is greater or E is
Yeah,
greater.
if your energy of the particle is greater than V naught, then
Sir, wave
why
vector equal to 2.
it will lose some energy, the potential barrier, right? It does. I mean, it should increase, right? It should not. Can
Sir,
you say
wave
some?
vector equal to
Huh.
sir, wave vector equal to 2 pi upon lambda.
That's the thing. Now, Sejal was asking, can you just tell me in some cases, if there any case where wavelength may increase also, or decrease also, Sejal? I can't
No,
think
sir,
that.
I cannot recall any example, but I was just
Sir,
mathematically looking at it.
step potential is also another example where
Okay,
the wavelength is
one
decreased.
more way I can answer this physically, that because when the particle is penetrating the potential barrier, it will lose some energy, right? So if it is losing the some energy, so basically your wavelength will be now redshifted, because after coming out that it has already lost some energy, right? So if energy is decreased, your wavelength should increase, right? Am I clear?
Yes, but
Yeah.
what if we look at it from the perspective of the
Hmm.
amplitude going down?
Amplitude
Okay,
will
that
also.
amplitude has nothing to do here because that tells
Hmm.
the position of the particle,
Right.
right? Not the energy.
Yeah, that will actually that will come because that will come from the continuity equation. The amplitude should match at this position, and also from the equation you will get the amplitude. Yeah, so amplitude will also decrease, right?
Yes.
सर
Amplitude.
जहाँ से मतलब वेव फंक्शन डिक्रीज होगा वहाँ से एम्पलीट्यूड भी डिक्रीज होगा ना.
Amplitude will decrease.
Yes, yes.
Yes. Yeah. Okay. Any other
So,
confusion?
sir, how
Yeah.
to mathematically prove this physical result that it should decrease whatever be the value of E or V naught minus E?
Okay, for that I have to again write the Schrodinger equation. Okay, so maybe actually I didn't get that, but I can share the solution in the YouTube maybe with the proper using the Schrodinger equation. From that I will use the conditions that continuity of psi x. From that you can understand easily how it will the amplitude will decrease or increase. You can try yourself, this will be very easy. From that you can find your amplitude will decrease here for this type of case. But
No, sir, I was talking about the wavelength itself.
wavelength, because I'm talking about the k vector, right? If you can find the k vector in this region, you will see this k vector, magnitude of the k vector will be root over 2m by h square square v naught minus c. Basically you will get a condition k in this region will be I times beta. Did you get my point?
Yes, sir.
So so what you have to do, you can just try after this class. So you have to find the the wave function in this region, the wave function in this region, apply the continuity equation of the psi x at x equals to a, and also apply the continuity equation del psi del x for this two region. You will see you can use the equation 1, that is the continuity equation of psi x. You can use that in the second equation, and you will get a relation between k in this region and beta in this region. So beta is related to V naught minus E, right? From that you can comment on that, and this is only depend on E, not V naught. There will be no minus V naught. So from that you can find you can tell the what is the magnitude of the k vector, and also lambda is inversely proportional to your k vector, right?
Yes, sir, I'm assuming that I've already obtained that result that K is 2m by h cross square, V naught minus E,
Mm-hmm.
and over there it is only E.
Mm-hmm.
But now, how can we be sure that V naught minus E is always greater or smaller than E? It could be either of them, right?
Oh,
Depends upon the
you are
magnitude of
asking
E.
about the particle energy greater than V naught. You are asking about that.
No, sir. We are saying that K will be small because V naught minus E will be smaller than E.
Okay,
Because,
so
yes, sir.
E may be negative. Then you are saying V naught plus E, right? So in that case, it will be different.
No, sir. So, yeah, I mean, so V naught minus E could be smaller than E or it could be larger than E. Accordingly, lambda could be smaller or could be larger than the
V naught minus
value in the
C
first
could be
region.
smaller than E. Okay. If
सर
both are
ये
positive,
सर सी सेइंग लाइक मतलब 1 इलेक्ट्रॉन वोल्ट एनर्जी का कोई पार्टिकल आ रहा है, ठीक है? तो अगर उसका वी नॉट माइनस ई 2 इलेक्ट्रॉन वोल्ट हो, मान लीजिए वी नॉट की वैल्यू 3 इलेक्ट्रॉन वोल्ट हो, तो उस स्थिति में वी नॉट माइनस ई इक्वल टू 2 इलेक्ट्रॉन वोल्ट, दैट इज द ग्रेटर देन पार्टिकल द एनर्जी.
okay. I got your
हाउ कैन
point
यू
now.
जस्टिफाई दिस थिंग?
Got your point. Oh, in that case, you can say, yeah, right. Right. Sorry, I was wrong then. Yeah, Sejal, you are right. Then that thing should not be applied here. I mean, that will be confusing here, right? Right. Then I think
Yes, sir.
continuity thing will be the greater thing here. Yeah. Okay.
Okay, sir.
Sir,
Yeah.
if the energy is greater than V naught, then the wave will directly go there.
Directly go there, but there will be some reflection also, because it's a quantum phenomena, right? So you will see, if you write the equation, there will be both plus k and minus k part, so there will be reflection also.
वन थिंग मोर सर.
Yeah.
सर आप ये K3 इक्वल टू आई टाइम्स बीटा बोल रहे हो ना? यस सर. ओके सर. सर मान लीजिए आप अभी इस स्थिति पे बात कीजिए, x इक्वल टू 0 और x इज इक्वल टू 8 के लिए, मतलब ये पोटेंशियल वेरियर है, ठीक है? यदि मैं वी नोट एल और पार्टिकल की एनर्जी को इंक्रीज कर दूं, तब टी और आर पे क्या इफेक्ट पड़ेगा? वो डिक्रीज होगा या इंक्रीज होगा?
Can you please repeat your question? I could not follow your question. एक बार repeat करो.
यस सर. सर पोटेंशियल वेरियर है ना ये, x इज इक्वल टू 0 से x इक्वल टू a. यदि मैं इस बैरियर की जो वेट्स है उसको चौड़ा कर दूं,
अच्छा.
ठीक है, और पार्टिकल की एनर्जी इंक्रीज कर दूं, ठीक है, तो आर और टी पे क्या असर पड़ेगा? कौन सा डिक्रीज होगा, कौन सा इंक्रीज होगा?
Okay. But magnitude of the potential bay is same, V naught.
यस सर.
Okay. So what is reflection coefficient for this case? I have to calculate
सर
that.
सर आई एम नॉट
You
मतलब
have
I am not what is the real question, but I have I will share that question.
you can share the question, so that will be better,
Yeah.
because we can. I'll next time I will be sharing the solution. Okay.
Yeah.
Okay. So I think this question doesn't need any mathematical solution for this particular question, right?
सर मैं ए और डी ऑप्शन में कंफ्यूज हो रहा था, तब पूछा था
No,
मैंने.
no. Option A is correct for this question.
हाँ.
Okay. So this is option A. Okay. Now coming to the Amit's question. Okay. This question I looked into it thoroughly. Now I am also a little bit confused. Someone may help me. I'll share. What I have done in this case. So Amit, are you there?
Yes, sir.
Okay. So please read the question very carefully. So measurement of magnitudes of the electric field and the magnetic field B in a plane polarized electromagnetic wave in vacuum leads to this following results. This is coming from the Maxwell's equation. That is del E del Y equals to minus del V del T. And
Excuse me, sir.
Yeah.
Sir, sorry to interrupt.
Yeah.
Because the argument was related to the previous question. There we were confused whether the lambda will increase or decrease. So we can explain it if we see that V naught could not only cause reduction in the energy of the particle, but it could somehow also increase its energy if itself it is an attractive kind of a potential. And
Yes, then it may increase, right?
yes. Yes, sir. It allows the particle. In fact, it attracts the particle towards itself and
I should not comment on that. Yeah, I didn't think
imparts
of
more
that.
energy to the particle.
It can release the energy to the particle, so that particle absorb the
Yes,
energy
yes.
from the system. I should not comment on that. Sorry,
Yes, sir.
sorry for that. I think that is not the correct way. Sorry. So, but I think in this part, only thing the continuity part is important, right?
Yes, sir. Yes.
Okay. Fine, but every time this type of question is asked in case of TIFR and other exams. Only at least one question will be asked with the wave function or probability density function. So okay, so this question, okay, also answer is given. Okay, so this question is giving this for a plane polarized electromagnetic wave, these two equations are given from the Maxwell's equation. Now in this case, electric field vector E, the magnetic vector B and the wave vector K with magnitude K can be written in terms of the unit vectors x cap, y cap, z cap along the Cartesian axis, as 4 options are given.
Sir, it is very easy question.
Okay, it is a very easy question. Okay, I will ask you then. Okay, so okay, there are 4 options. I will not read the options again and again. Answer is also given. Okay, so can you please tell me how to solve this problem? Then I will discuss my solution. Harish, this is very easy.
yes sir, very easy.
Yeah.
सर हम जब ये EM वेव इन वैक्यूम में पढ़ते हैं ना, तो हम हमारे पास एक एक्सप्रेशन मिलता है डेल स्क्वायर एफ अपॉन डेल जेड स्क्वायर इक्वल टू 1 अपॉन वी स्क्वायर डेल स्क्वायर एफ अपॉन डेल टी स्क्वायर. ओके, तो यहाँ पे जो ये लिख रखा है ना डेल बी अपॉन डेल वाई, yes sir, that is the it is not a del v upon del z. In the expression del v upon del z, then wave vector in the z direction, but instead of z there is y.
That I
So
understand.
wave
So
vector
from here
must
you
be
can say your wave vector is along y cap direction.
yes sir,
Either y cap or minus y cap. You can't say that, right?
there is another option. Yes sir, yes
So
sir.
I could not. Okay, I'll share the formal way, but I could not segregate the possibilities between B and C. Okay, I thought so. Amit, where in which exam this question
Yes,
was?
I'm also confused with that B and C.
B and C. Okay, I I thought it will be very easy. Then when I looked into the options, then it was confused. Okay, so you did. I think you did in the same way, right? Sorry, I forgot to attach the solution. Okay, just give me 1 minute. I forgot to attach the solution actually. Just wait. Just hold for 1 minute. Please note down the question. You can try, and if you get the correct answer, I mean you know the answer, please let me know. I will also try, I mean, to get why C is only the correct option here, because I could not recognize here the difference between the option B and C. Both should be correct, but I don't know why. I have to check. Just wait.
Abit,
And just 1 minute. I will share the solution. I forgot where I kept the thing. Okay, just give me 1 minute. Okay, I got it. Okay. Just okay. It is taking more than 1 hour.
Abit, in which year this question was asked?
Amit can say. I don't know from where.
2015, I guess.
Sorry.
2015.
2015 TIF.
Yes.
Okay, 2015. Okay. Just wait. Okay. Okay, I am sharing my screen. Is my screen visible?
Yes, sir.
Okay, fine. So the confusion, I think Amit also has the confusion here. So I will not explain the equations again and again. I think you know this thing. So I will just concentrate on this first two this equation. So here only you have special part, special derivative with respect to y. So your only del y terms are sustaining here, right? So this means your k vector should have only y component. Is that clear to everyone? Any doubt?
clear, sir.
Okay, so now this magnitude of ky can be plus minus ky, right? It may be negative, right?
Yes, sir. Yes, sir. Yes, sir.
Both will satisfy this equation. You will see. You will just check from this because it is coming from the curl cross C, it is coming from the curl cross B. If you just expand this thing in the cross product, you will see both thing will satisfy the plus minus ky. Okay, so now curl cross E can be written by this. Why only this term? Because only ky term is sustaining, other than that other terms in the expansion will be 0, and also in terms of B. Now you have to look into the equation, options, because here both possibilities are possible. Either it may be Ez or maybe Es or maybe both, combination of both, because plane polarized is means it will remain in a plane only, right? It may be in the xz, I mean in plane other than x, along the x cap or z cap, right? The normal of the plane. So here only the options with this y cap direction, your B and C options are here. You can see only k vector is along y cap and minus cap, only B and C is correct there. So only in between these two options you will have the correct one, and from that you can easily find that your E vector is along x cap. So from here you have to take the help. But even though I could not find, if you are taking this and k vector is along plus minus y, so according to that your v vector should be minus plus b z cap, right? Amit, am I right?
Yes, sir.
So now the question is, we have to find which sign is correct. So obviously we know the answer. So as Amit shared, so minus bz cap it should be b vector. So k should be ky cap. I am also stuck in this case. Okay, I could not find a way. Can anyone please help me now? I mean, if can anyone say anything how to proceed after that? Any idea?
सर ई क्रॉस भी निकाल कर देखते हैं.
E cross B.
Yes.
E cross B, if you take the x cap and minus z cap, it will give, you will see both the options are correct. Right, Amit?
Yeah.
Yes, sir.
That's the confusing part. So I have to check. I will check the questions also from this is TF for 2015, right?
Yes, sir.
I'll check, and I don't know. I mean, after that, how to proceed? I don't have any idea. I'm also confused. First, I thought it can be solved because I think I have replied to you because, but when I saw the options, then I got confused after seeing the options. So um, I'll try. Okay, Amit, just think about it
Sure, sir.
because I don't know how to proceed. Sejal, do you know how to solve this after that? Do you have any idea?
No, sir, I'll also have to think.
Okay, so just take a screenshot of this question and try to solve this. Okay.
Okay, sir.
Okay. Okay. I will also try. If I get the answer, then I will tell you, Amit. I mean, why it should be C not B. Okay.
Yes, sir. Sure, sir.
Okay. So you downloaded this question from the TIFR official website?
Yes.
Okay. Okay. Then it should be correct. Okay. Then I will check. Okay. And
Sir, can I ask one doubt?
yeah, you can ask.
So it's from solid state,
Mhm.
and we have a triangular lattice in 2 dimensions, and now my question is, why should it be a primitive unit cell, a triangular one in 2 dimensions? Why should it not? I mean, why should it be primitive?
It should
Yes,
be.
sir, I can give this explanation.
You have given that problem, right, Harish?
Sir, I solved it.
You solved it?
Yes, yes.
Then you can share the solution.
Yeah.
You can tell.
Can you share me proper question?
Uh, Sajal, can you repeat the question?
Uh, Sir, the question is that a triangular lattice in 2 dimensions, we have to state whether it's primitive or not primitive.
Okay. Yeah, it comes to Harish now. Harish, can you answer?
Where is the lattice point belongs?
Huh?
Sejal, where is the lattice
On the
point belongs?
corners. On the
On the
corners.
corners. The contribution on the corners, that is the 16 by 3, it is the equivalent triangle.
Yes.
60 upon 1 upon 6 into 3. It is not primitive.
Why it
Yes,
is?
that's what the problem is. It should not be primitive. It's half only, not one.
Yes.
Okay.
But
It is given that
the
this is
answer is it
primitive?
is. Yes, sir.
It is the FCC.
It is?
No, 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 not FCC.
It's not FSC. Triangular
If
lattice.
if lattice points only belong to the corners, then it will not primitive.
No. Triangular
In what
lattice.
way can it be primitive if it's
I'm,
triangular
I'm,
and
I'm,
lat?
I'm thinking that. Just wait. If it is triangular, then previously. Okay. So that is 60 degree. So your A and B vector is
Sir,
making 60 degree, right?
if we have if we consider four corners and take the diagonal of a face, and means if we join three diagonals and make a triangle, then it will come, because all the sides will be equal and it will form a 120 degree, means 60 degree.
So in that
Three
case,
xyz axis,
hmm. No,
and
she is
we will
asking
just
2D lattice, right, Sejal?
Yes, sir.
Okay. Okay, I'll note down the question.
The
Yeah,
exact
yeah.
question is
Uh-huh.
the exact question is which of so I'm given a triangle, a square, and a hexagon, and I'm asked that which of these can be primitive unit cells of a Bravais lattice in 2 dimensions.
Okay, it's Breville lattice already it is given. Okay.
Sejal, Sejal, please share the this
You,
question in the group, Telegram group.
also, Sejal, can you write the question properly and you can send me the mail so that I can discuss in the next class this question?
Okay, sir, I'll
if
share it.
she can present here.
You can also no, you can present here also, or you can. Okay. Anyway, I will be discussing the next slide because it's already 7:54. Already 2 hours. It has gone. Okay. So
Okay.
maybe you send the question. I will discuss the solution properly, and also I will try to answer this question, Amit's question, if I can. Okay, Amit.
Yes, sir.
Okay. Also, you guys please
Uh,
try this. Yeah,
Sir,
yeah.
I'm not sure if I have your mail ID. Would you please
Yeah,
share
yeah,
it
yeah,
again?
yeah, yeah. Sure, sure. Just wait. Just wait. So I am stopping my presentation. Okay. Sometime I may not see the chat box. Please, someone can help me to get the answer from others. Someone has written the answer. I didn't see. Sometime I was engaged in the PPT. Okay. I will write the mail ID. Okay, I have shared, and one more thing. Just I will just give me 1 minute. Cyril, did you get my mail ID?
Yes, sir, I got it.
birishroy@ic.ac.in. Just wait. Okay. Um, okay, fine. And also, I think there are no new people. I think one or two. Okay, please subscribe to my channel. I have just shared the link. So I'll be uploading the solution videos in my channel. You can subscribe my channel, and if you like the videos, please like that. Okay. Okay. Please send me the question. But Harish, you sent something.
Sir, I am sharing the Telegram group link that we can get the schedule question.
Oh, okay, okay. But I am not using the Telegram. Okay, you guys can
No,
discuss.
don't worry,
Okay.
sir. Don't worry, sir.
Yeah, yeah.
We are in the.
Okay, no problem. Okay, fine. People, you can guys, you can share your questions, but it's taking too much time. Although we are asked to take the classes within 1 hour, I will try to cover the questions, but the time is limited, so maybe I can't make everyone happy within this short duration, but I will try to solve all the questions. Okay, right?
सर नेक्स्ट टाइम से हम ऐसा करेंगे कि हमारी जो भी प्रॉब्लम्स होगी वो ग्रुप में शेयर करेंगे हम पहले डिस्कस करेंगे फिर आपको फॉरवर्ड करेंगे
Okay,
दैट
okay.
इज द
So one more thing from my side, the concern is so basically I can there is no problem. Sejal, okay, she is representing the course. Sure. Okay. So okay, I can take a screenshot, but I can't see anything because this is too small. Now, okay, okay. I will take the screenshot. Okay, just wait. Okay, okay, okay. I'll explain this. Try to explain this in the next class. Okay, Sajal. I have taken the screenshot.
Yes, sir.
Thank you, Sajal. Yeah, so the thing, my concern is that because I have to ask the NPTEL team, because we are asked to, I mean, discuss the previous year GATE solution, because they are making a repository of GATE phase papers. Okay, so if I spend the whole time to discuss the doubts of from your side, then if there is no problem from their side, then I also don't have any problem. I have to ask them because they also need a repository of previous year gate field solution. So I have to cover this up. And only thing is I have to spend only 1 hour within a week. So because I have other work also for my research. So I have to ask them. Anyway, you send me the doubts. Today I have taken 2 hours classes, but that is okay. Okay, Harish.
So we are very sorry for that.
No, it's okay, it's okay, it's okay. I knew that it will take much time, but what Harish was saying, I have to discuss the first your doubts. So if they are okay with it, then I have no problem. I have no problem. I can just go with the solution because they can't make the repository with these questions because this is not the gate questions, right? These are textbook or from another examination, but because this is only focused to the gate physics, so that's why. Anyway, you can send me the doubt. I'll try to cover this up, and also I'll ask the NPTEL team. Okay.
Okay, sir.
Okay, fine. See you guys. Yeah.
सर 1 मिनट
हाँ.
सर एक डाउट है पॉइंटिंग वेक्टर से रिलेटेड सर चार्जिंग और डिस्चार्जिंग कैपेसिटर के लिए पॉइंटिंग वेक्टर की डायरेक्शन की मतलब कैसे होगी सर
Harish, can we discuss in the next class this thing, or you can send me a email?
श्योर
I have to go because
ओके
it's already 8. Okay.
यस सर सॉरी
Okay.
सर
You send me a mail. Okay. You send me a mail
sir.
with that question. Maybe I will discuss in the next class, or I can send you that.
just tell me
I have to.
when the charge capacitor is charging then what will the direction of electric field
Okay. If it is charging, then
yes
what it should be? Because you are it should be because electric field is going, displacement current will go from this plate to this plate. So electron is going from this to this. So in with respect to what you are asking, I mean the electric field direction, applied electric field, applied potential.
Not sir, just directly ask that when it's charged, when the capacitor is discharging, then find out the direction of the pointing vector.
Oh, pointing vector. Okay.
Yes.
Okay. Okay. Field, electric field is a, magnetic field is this, A cross B. Energy is losing. I don't know. I have to check. I have to check the mathematically because your electric field is along the your from this plate to this plate, and magnetic field is circular loop, right?
Yes, yes,
So
yes, yes.
E cross B, your
सर मैं इलेक्ट्रिक फील्ड की डायरेक्शन में ही कंफ्यूज हो रहा हूँ बस
electric field will
क्योंकि
be along from this plate to this plate, right? I mean, why it should not make any difference, right? Electric field should from
सर
because it's charged plate, right?
यस
It will reduce. It will. In the case of discharging, it will reduce. The magnitude of the electric field will reduce obviously because charge is getting
डायरेक्शन
discharged.
चेंज हो जाएगी क्या सर
Hey, it will
मतलब
change, right?
डिस्चार्ज होगा
Yes, it will change because you are diminishing the charges from the plate.
ओके मतलब पहले जब चार्ज हो रहा कैपेसिटर तब
हाँ
मान लीजिए इलेक्ट्रिक फील्ड की डायरेक्शन जेड डायरेक्शन में थी अब वो
हाँ, if you
डिस्चार्जिंग
consider
हो रहा
that
है तब
direction
उसकी
z direction.
माइनस जेड मतलब उसके विपरीत दिशा में हो जाएगी
The electric field direction will be same, but the rate of change will be with respect to your what I am saying. Your direction will be same in the both the cases. Why it should be different? Because plus minus charge will not, I mean, change with itself, right?
ओके सर आई विल सेंड
Ah,
द
you can share the
प्रॉपर
question.
क्वेश्चन
Yeah, yeah, that will be
ओके प्लीज एक्सप्लेन इन द टू वे ओके
okay. Okay, fine.
नेक्स्ट क्लास
Okay, fine. Thank you, boys.
थैंक यू सर
Thank you.
Thank you, sir.
Thank you. Yeah. Bye bye.